Hi, my name is Sarah Davis. I'm a graduate student in the Project Dragonfly program where I am studying conservation biology. As part of my graduate work, I developed and launched a citizen science initiative called Mapping Microplastics. The goal of the project is to engage a wide range of audiences in testing their local waterways for evidence of microplastic pollution. Plastic pollution is probably pretty familiar to us. Microplastics are tiny plastic pieces smaller than 5 millimeters. Because they're so tiny, they often become almost invisible to us and difficult to study. When they ultimately end up in our waterways, microplastics are documented to create significant ecological damage. It's a serious and urgent issue, and the first step in solving the problem is understanding it. This project will collect critical baseline data about where microplastics are and how dense the pollution problem is in different areas. So why citizen science? The first reason is efficiency. Citizen science researchers can collect a huge amount of valuable data that would cost more formal research methods much more time and funding to collect. More importantly, at its core, I developed Mapping Microplastics as an educational tool. For many, including myself, the science research community can often feel like a place for experts only. As a woman in science, I'm passionate about creating opportunities for traditionally underrepresented groups in science to participate in real, important, hands-on research. As a science educator, I rely on citizen science projects because they're documented to help kids develop their identities as scientists and to encourage participation in STEM well past the activity's completion. I'm eager to engage Miami's global community to recruit participants of all ages and backgrounds. So how does it work? I developed this simple procedure from published lab studies and with feedback from leading microplastics and fluorescence experts. You just scoop up a water sample, filter out the debris using a coffee filter, and then apply a special stain called Nile Red. Nile Red will stick to any microplastics that are present and cause them to fluoresce or glow brightly. Participants just take a photo and upload their results to the project's website, where they're added to an interactive GIS map of data. The procedure is simple and the materials are inexpensive. However, things like blue flashlights and Nile Red Stain are not typically what interested volunteers might have lying around their classroom or home. The funding I'm requesting will support 30 groups to participate and build an audience of future participants. Perhaps one of those kids or adults might be the next researcher to develop a solution. With your support, Mapping Microplastics will help build a global community of conservation advocates. Thank you very much for your consideration.